Sorry, guys. Yeah. So we start day two of Virtual Max today, and we have an opening session taken up by Oregon Systems, and they specifically focusing on OT and IoT cybersecurity for critical infrastructure. So we have a couple of gentlemen here representing Oregon Systems. I'd like to introduce Mr. Mohammad Siraj, who's not here with us, but he'll be joining soon. We have Dr. Manu Nair here, who's the General Manager for MENA region Oregon Systems. Followed by, we have a couple of colleagues, Mr. Waqas, Younas, and Mr. Nidhin, who would be taking us through a lab demonstration, which is going to be a live session for later this session. And also to represent here a couple of vendors from their end, we have Mr. Ilan Searle, who's from service service industry, right? Yes, wonderful. And then we have Mr. Bachir Moussa from representing Nozomi Networks. And we have Mr. Ilan, who's from, just a minute, I'm so sorry, I didn't catch the name. Mr. Ilan, where are you?
Siga-OT Solutions.
Wonderful.
Siga-OT Solutions.
Wonderful, Siga-OT. Wonderful. So I'll leave the session now to Mr. Manu Nair to take over and lead this session.
Thank you, Ronaldo. I think you have to give me the access.
Just a minute, sir.
Yes.
Okay, fine. Thank you. Good morning to all. So my name is Manu Nair, General Manager of Oregon Systems. So I will give a quick introduction about Oregon Systems. So we are one of the leading cybersecurity distribution and value-added service provider in the region. So we mainly focus on the OT cybersecurity product portfolio. And we have our regional headquarters in Bahrain, and also we have presence in Saudi Arabia and UAE. And very soon we will be presenting our footsteps in Oman and Kuwait soon. So I'm not going to spend much time on introducing Oregon. Most of the people knows about us. So I'm just straight away going to the topic because of the time frame. So we know that there is a change in OT cybersecurity arena, and we are talking about digital transformation and also OT IT convergence. So when we talk about this scenario, so what are the things we need to really consider? So when you talk about a critical network or a critical environment, so there are certain things we need to really identify, and we need to really address those risks actually. So the most important thing is to understand the assets sitting inside the critical network. So some of the critical assets are very old and some of them are new. And so how we are going to identify all these assets. Once we identify the asset, then how we are patching and how we are understanding the vulnerability associated to that one, then how we are trying to mitigate all those risks. So this is very important for us to know all those things. Then the second thing, you know, that most of the organization or government bodies are coming with the compliance and standards. So how we are going to meet all those cybersecurity standards specifically related to OT cybersecurity. Then another main thing we need to see that, you know, do we have enough skill set available to do all those things? So we know that, you know, OT cybersecurity was an isolated area before, so now it is coming to a connected world. So when we come to the connected world, so we require enough skill set to understand the risk associated to that one and how we are going to mitigate all those. Then we know that finally, if any attack happen on the critical network, that is literally affecting the production as well as the economy. So how we are going to handle all those things. So cybersecurity as today, actually, if you see that it's an emerging, so we can say acceleration in technology adoption in OT cybersecurity area. So we know that IoT, IIoT, medical IoT, all those things are in place. And most of the technology vendors are new, and these companies are mainly focusing on developing their technology, not based on cybersecurity. They are focusing on their sensor technologies. So when we are deploying a new IoT or IIoT technologies in a critical network, so what are the risks associated to that one? So we know that there are limited budgets are allocated when we talk about cybersecurity, specifically on OT and IoT currently, but the attacks paradigm is going to increase from 2021 onwards, because we are adopting a lot of IoT products inside the network. And also we have a lot of very old assets are sitting inside the network, how we are going to address the risk associated with that one. So that's why we design a special architecture, address the threat associated to this network from level 0 to level 4. So we mostly follow the Purdue concept, not the OSI model. So how we are going to deploy a level 0 to level 4 protection to defend the OT network and meet the standards and comply with the requirements. So we know that the most important thing is our asset actually, which is a key element in our network, which is associated with our protection. So how we are going to address the level 0 protection. So level 0, when we talk about level 0, there is no IP capability. Most of the devices, there are all electronic or electrical devices, such as centrifuges or any other motors or HVAC systems. So all these things, some system doesn't have the IP capability. So how we are going to understand and how we are going to predict the potential failure of this critical assets. So we require a level 0 monitoring solution. So we sign up with the Siga-OT. Siga-OT is one of the pioneer in understanding the level 0 protection mechanism. So they have the full-fledged capability of understanding the data coming from assets who doesn't have an IP capability, as well as it start reading the data from the PLCs, which is a communication towards the assets. So we have a two-way understanding. So why we are doing this, we have a specially built artificial intelligence platform to understand the cyber threat as well as the mechanical fault on level 0. So that is on the level 0. Once we completely understand the level 0 protection mechanism, then we need to go to the level 2, which is our PLCs or RTUs, HMIs, all those devices are sitting. So we need to understand how we are discovering all these assets in the network and how we are doing the macro segmentation, how we are going to apply the certain encryption technologies here actually. So once you identify the assets, we need to understand how we are going to manage these assets, how we are going to segment this asset, and how we are going to cloak this asset, and how we are going to eliminate the threat associated with it. So we have Nozomi in picture to understand the assets, and we have TDI console work platform for the asset management, and also we have a technology from Temper Network, which is doing the complete network invisibility. Then we go further actually. So we have to have the complete understanding on the historian data sets there and how securely we are taking the data out from the OT to the IT. So we need to understand how the deep packet inspection happening there. And also we need to understand how the historian works. Is there any manipulation on the historian data? So we have a specific technology comes from Aperio, so which can talk to the historian and also understand if there is a data forgery happen on the historian system. And also through the historian, we are also can understand the sensor fault mechanism. So that also we are doing from layer 2 onwards. Then we have the complete unidirectional gateway system, because we know that when OT connected to the IT, so there is always a threat associated to that one. So there is a potential possibility of malicious people come from OT to IT. So we have the data diode solution, which is sits on the perimeter of that OT network, and it prevents the complete access to the OT. So it is a hardware-based design. So it's completely prevent, and it's an unhackable mechanism. So we deploy that one on the edge of the OT network, and also we do the micro segmentation there. So the most of the network, we know that the red side actually the interface which is communicating to the OT network are exposed to the open network. If there is a DDoS attack, so the data will not reach the SOC actually. So we need to hide the interface of the data diode, which is sending the data from the critical network to a non-critical network. So we need to do the complete clocking there actually. So we are using Temper Network to do the clocking. So I will show you the next slide how this architecture, our technology is deployed in an architecture. Then finally, we have the SOC integration. So we have the complete visibility analysis predictive platform, which can be integrated with the SIM solution or any other analytical platform. So this is how we design our architecture concept from level 0 to level 4. So we have few of our partners are available here, so they will be giving you more detail about how the solution works in each layer. So this is a complete partnership portfolio for Oregon Systems. So you can see starting from console networks to the Nozomi. So we are covering the end-to-end solution portfolio required to meet the OT cybersecurity requirement and the standard and compliance. And also we have the Redboard solution. It's a US company. We are partnered with them and we can leverage their capability and also Oregon skill set to provide you any kind of OT cybersecurity services like SCADA pen testing or a compliance audit. All those capabilities can be provided to our customers. So this is a high-level design from our engineering team. So they visualize the deployment of our solutions, our technology vendors application to the different levels of a FIDU model. So it starts from a critical asset. You can see CCTVs, you can see the oil tanks, so which we will demonstrate to you later in the presentation how this solution works in a live environment. So we can see that Siga sits between the actual assets, which is the oil tank, for example, and the PLC start reading the data. So we have a deep packet inspection as well. So we understand the cyber attacks as well as the mechanical fault. Then starting from there, so we can see the different mechanism there. We have a cloud platform there. So if you are looking for an IoT private cloud, we have that capability. And also we have an IoT gateway comes in. So if you have an IoT or IoT solution there, so we are completely ready to take the data and send back to the platform where it's required. And also we have the complete OT operational platform, which is a TDI console works. So which completely recording all the access towards the OT, and it's have more capabilities. So that we'll discuss later. So this is the high level design and architecture. So we are happy to give more information and more elaborated technical session if anyone is interested. So that's from my side. So I don't want to take much time. So now I'll leave the presentation back to the team. Thank you.
Thank you, Dr. Manu, for that wonderful introduction, and hope the attendees have some insights about our solutions and the services that we provide across the Middle East region. So right now, without further ado, as Dr. Manu explained, we have a couple of our partners, in fact, 3 of our partners with us joining in this meeting, and to give us some insights and some great valuable services and some solutions from level 0 upwards. So first up, we have Ilan from Siga-OT Solutions. That's from the level 0 monitoring and protection perspective. He would like to showcase the solution for you guys. So Ilan, up to you.
Thank you so much. Can you just give me, please, sharing possibilities? Thank you, Nidhin, and thank you, Dr. Manu, for the wonderful introduction. It's quite a privilege to be part of this conference, and we're looking forward to having this session completed in a very successful way. Siga, as mentioned, is a proud partner of Oregon Systems in the region, and we are looking forward to a very strong partnership ahead of us. We will discuss today the importance of level 0 monitoring, out-of-band level 0 monitoring as part of an holistic approach, which was just presented to you by Dr. Manu. Why is it so important to also consider level 0 monitoring as part of the OT cybersecurity in general? Siga-OT Solutions was founded in 2015, and we have already validated and tested the solution in many, many different applications, including very critical infrastructure and other verticals as well. I think the challenge was already articulated very well by Dr. Manu, so I won't go very much deep into it, because we know that we're trying to converge IT and OT together today, and we were trying to connect more and more devices. But what we're still need to keep in mind is that control networks are still vulnerable. We have not sealed off everything that's related to our control networks. And that's why we need maybe a different approach to understand how to address OT assets. As we all know, control systems in general, as well as control networks, were not designed initially with cybersecurity in mind. This was nothing even on the table until the past decade. And once we were aware about the vulnerabilities that are around our control systems and our control networks, we built many systems and many methodologies in order to secure our control systems, to secure our networks, in order to understand that everything would be safe. And that's very important to do. However, the question still abides, is it enough? Are we looking at the right direction? We all know that OT and IT are different in essence. When we talk about the real definition of what is an asset within IT as what is an asset within OT, we have a very different answer. In IT, what we are trying to protect as an asset is data or communication networks, etc. In OT, what we are trying to protect initially is our actual OT assets. OT assets meaning the physical layer where our equipment and machinery are working and our production processes are actually functioning. That's the main asset that we're trying to look at in OT assets. And if we recognize that, if we understand that that's what we're looking for, that's what we're trying to protect, we need eyes on the process. We need eyes to protect the OT from the deepest layer possible within the Purdue model, as you've seen earlier. And that's the approach that Siga has been implemented since its beginning. So when we look at the Purdue model and we see the different layers, we understand that the layer 0 is the real asset. That's where our machinery and that's where our processes are happening, real world processes. And what is the language? Real world processes? They speak to us through, in most cases, through electrical signals. You know, the control electrical signals coming from the sensors and actuators in level 0, emitted as 4 to 20 milliamps or 0 to 10 volts and other types of electrical signals as well. And those electrical signals are completely physical. They're not digital. They're not data protocols in most cases. Those electrical signals come up to the PLC layer where they are transmitted and digitalized into our OT network. However, this also gives us a vulnerability issue because if we know that attackers can enter into our digital realm and manipulate the data within our network, then we will be blind to what is happening within level 0. They will take advantage of this isolation between the digital world and the physical world, the analog world, which is level 0 monitoring. And that's why we think that we need to have a platform that would also mitigate the possibility to use this kind of vulnerability and make sure that what's happening within level 0 coincides and correlates with everything you're seeing in the upper layers in your network. That's where the importance of level 0 comes from. So the Siga platform has, we constructed actually a very seamless type of integration into the level 0 monitoring signals, where we acquire these electrical signals, duplicate them and monitor them unidirectionally within our network, completely isolated from the network itself. So we take these electrical signals in between the critical assets, in between the IOs or the signals within the sensors and actuators before they become digital packets within the PLC. So we take them right in the interval between these two assets. And we take these electrical signals and duplicate them. And the reason we do this is because the electrical signals have the most rich and unfiltered area within the OT network. So we actually can see more and monitor more within the OT architecture itself. But most importantly, these electrical signals are completely unhackable by essence because they're not digital. So what we are doing is creating an environment that's completely isolated from the network and unaffected by it. So anything that's happening within the network, if a hacker was able to penetrate the network and manipulate the data there, Siga will never be affected. And we will always be vigilant to show what is actually happening, what is the status of your really critical assets. So we take, as I said earlier, we take these electrical signals, we duplicate them into our platform using a hardware box that we fabricate. And once we do that, we can provide our real-time monitoring and granular visibility. We also have AI applications, machine learning capabilities that monitor these electrical signals, monitor the process, and will tell the users and operators when an anomaly happens, when you have a possibility for an attack or an operational failure that you want to know about. And that way we would be able to alert about those situations. So let's take an example of a normal use case. There's several use cases where level 0 monitoring is important, as I just earlier showed you. And we have the Purdue model again, and we see the different layers. And in certain situations, someone was able maybe to penetrate, and there's many vectors, and we all know about them, beginning by channel or different ways of getting into the system from in advance, and other penetration ways as well. And once someone got into the PLC, it's very difficult to detect what he would do there, or what type of malware he would be able to manipulate the data within level 0. However, in this type of situations, we are completely below the radar, and we will still show what the occurrence and the status of the level 0 assets as they are in true form. So we will not be affected by these types of attacks. And this is just one example of how level 0 monitoring is a very proactive and very resilient solution as a holistic approach to other solutions as well. So if I summarize the value proposition of the level 0 monitoring, we see that level 0 monitoring can provide highest resolution into OT processes. It is a complete out-of-band solution because it's not connected to the network and unaffected by it, which also enables cyber resilience and remote monitoring, which is very important in these days. We have the AI anomaly detection engine, which will autonomously learn the normal behavior of any type of process and will alert when something wrong is happening within the process, and also will provide independent data archiving for forensics and recovery, again, stored in a separate location, not part of the network itself. So these, I think, are important issues, and the significance of level 0 was already validated in different organizations. There's different regulations that already recognized level 0 monitoring, like you can see here on the left, where regulation was also given control measures to include level 0 monitoring as part of the OT cybersecurity, and also different partners and customers we have, which are part of our framework, including power, energy, oil and gas, water, and different other manufacturing areas as well. I'd like to thank again Oregon Systems as being our valued partner in the region, and I hope to see a good traction from this conference and from others as well. Thank you so much to the team, and I'm taking it back to you.
Thank you, Ilan, for that brief introduction about Siga to our members in the meeting. Hope all of you got a flavor of what exactly Ilan was explaining and why level 0 monitoring is extremely important these days, and to defend the cyber attacks especially in this region. So without further ado, from level 0, as we know that the next one coming up in the Purdue model is level 1, which is nothing but the PLC, the RTU, the process control devices, right? So how exactly we deliver, or how exactly we are doing the asset discovery using Nozomi networks and leveraging the threat intelligence and asset intelligence associated with all these devices. So I would like to welcome Bachir Moussa of Nozomi Networks to give us what exactly the solution does. So Bachir.
Thank you, Nidhin. Thank you very much. Let me just share my screen. Good morning, everyone. Thank you for joining us at this time. And I believe everyone can see my screen. If someone can just confirm, I'll get started.
Yes, Bachir. Yes.
Perfect. Great. So I've got a straightforward agenda for everyone today. I would start with a bit of an introduction on what we do and why we're here, some of the main challenges we're seeing organizations face, what our mission is as a company. I'll share a bit of a deployment architecture to give you an overview of where we stand, a bit of our partnerships, and finally, I'll summarize. So to get started, Nozomi was actually started in Switzerland, and that's where our European head office is, and where we do our research and development. So from day one, we've had a European connection, and as the organization grew, we've moved our global head office to San Francisco. But very importantly, the next biggest office after that is actually here in Dubai, where we service the region And we're proud to say one of the largest offices Nozomi has is based in the Dubai, looking after the region. And that's where I am based myself. From the type of organizations we work with, you can see them listed here on the screen. And we've got leadership positions in those top verticals over here. The different verticals highlighted in bold over here are the ones where we have references here in the Middle East, specifically in the Gulf region. So as you can see, we have been working closely for many years in the Gulf region with organizations across different verticals, and we're very lucky and proud to have them as our references and as our customers. If anyone has any questions around what we do here, please send them to me in the chat and I'll respond to you. So what are the challenges that we are seeing? I really like this slide because I actually put it together based on multiple conversations I've had with different organizations across the region. So when we ask them, what are the challenges you face? Each organization either mentions one or all three of those top three challenges here. The first one, and the first main challenge, which is very critical, is that they're unable to accurately visualize their network and build an automated or proper asset inventory. We have seen organizations that have asset inventories that are 80% inaccurate. This means they really do not know what's happening in their network. They don't know what they have in their network. And this is causing them lots of headaches and lots of issues. So when you don't know what you have, obviously the biggest cliche out there is you cannot protect it. So because they don't have a proper asset inventory and tracking of assets, they are unable to detect cyber threats or cyber attacks till they actually bring the network down. We see lots of news articles that a factory has shut down, oil and gas manufacturer has closed down their plant for a few days. And this is because they were hit with an attack and they couldn't detect it earlier on. And the third issue, again, they could have a massive failure in a part of their network, and it takes them a long time to fix it because it could be in a part of the network they didn't know existed or they didn't know they have assets there. So fixing and troubleshooting or replacing those assets could take a very long time. Those challenges are very common, very significant, and very important. They have been around for a very long time, but up until recently is when we started seeing organizations take action. And the question is, why now? And it's because of those 3 points over here. IT and OT convergence is really happening. We are seeing them coming closer and closer together, which is really benefiting the organizations. They're now able to develop digital transformation plans across the whole organization rather than just part of it. They're leveraging Internet of Things in a better way to become more efficient. But as they come together, the main challenge that arises is those OT networks are no longer segregated. They're no longer out there on their own, air-gapped and secure. They're all of a sudden connected to the IT network, which in turn means they're connected to the outside world. This has resulted in organizations seriously looking into taking action and protecting themselves against the challenges. And this is where we come in as Nozomi Networks. Our mission has always been from day one to help organizations see, detect, and unify what they have on their network. If we look at it on a step-by-step, firstly, in terms of seeing what's on their network, we provide full visibility into all the assets on the network. This means what vendor this asset's from, what firmware it's running, how is it communicating to other assets, what protocols is it using, and then what vulnerabilities they may have. This is all provided to you as soon as the solution is plugged into the network. And the best part is this is done passively. We understand OT. We are not there to provide an active solution that could be intrusive to your network. We are doing all this in a passive manner. Once we understand the network and we learn the network, we start detecting any threats, risks, and anomalies that are happening in the network to help detect attacks early on. So because we are a passive tool, we don't do preventative measures. We partner with other technology alliance vendors, which I'll mention later, to provide the full see, detect, and prevent. But how do we do the detection? For known attacks, we have our threat intelligence service that's developed by our own labs, and it uses feeds from multiple different parts out there, from OEM vendors themselves, from ICS cert, we look at CVE scores, etc., to build this threat intelligence service that's updated every 2 to 3 days and fed to our appliances. For unknown attacks or zero-day attacks, we leverage our anomaly detection service, and that's built into the appliance, and we are able to detect any anomalies that happen on the network to help you identify any threats early on. So the detection happens both for zero-day attacks and for any known malware or viruses out there. And finally, regardless of the number of sites you may have or locations, whichever countries they may have, we provide you with a secure and centralized visibility and monitoring solution across all your environment. I hope I'm on track so far with what's happening, and I would like to share a sample deployment architecture to give you an understanding of how we work. This is one site in an organization, and this blue device over here is the Nozomi appliance. It can be deployed across level 1, 2, 3, or 4 in your network, because all we need is a connection to a span or a mirror port on your switch to provide you with the full visibility and detection solution. Regardless of the number of switches you have or where they are across your Purdue model, we can connect them because we have appliances that can scale, and each port on our appliance connects to one switch. So you can have one appliance anywhere across level 1, 2, 3 connected to multiple switches of your network. Once we detect something, we do multiple things. One, we can send it to our central management console so that you can see centralized information, and that can be integrated with a SIEM to correlate information and then share it with your SOC. So if you have a SOC, you only require one integration point with Nozomi, which is our CMC. We can send it to a firewall, and if needed, we can take preventative action through the firewall, such as kill a session or block access to a certain node. We can also integrate with a NAC, so the NAC can quarantine an asset based on the information we provide. So as you can see, there are multiple things that can be done with the information that we provide. And this information, as I said, is all provided passively. No solution or company is strong without partnerships. And we are very glad to have partnerships across all those different vendors. But the key ones I want to highlight is over here. We support the protocols, and we partner with all the OEM vendors highlighted on the slide. And what this means to you is that the level of visibility we provide is very accurate and detailed, plus the level of detection we provide is also as accurate and detailed because we support their protocols. And I thought I'd put the slide to give you a bit of an idea of what to look for when partnering with an organization. The first one, which we've seen is very relevant, is the regional presence and the references the organization has here in the region, because this means that partner understands what's happening here in the industry and can better support you. It's important to work with a partner that does not cause you any network disruption and does not pose any risk of giving you a network disruption. You need to also look at partners who have strong partnerships themselves, partnerships with technology alliances, partnerships with strong distributors, partnerships with OEMs, etc. Also, since we're in an OT space, it's also very important to find a partner that understands OT. Do not, there are many companies out there who are IT companies that have started to do OT to jump on the bandwagon, whereas it's important to partner with someone who's been an OT solution provider from day one. And finally, look at companies who are always innovative, who are always challenging the norm. I'd like to give a Nozomi example here, where 2 weeks ago, we released our Vantage product, which is one of the first, or if not the first, OT in the cloud service that we're providing to our customers. If you'd like to know more, please send me a question on the chat. And finally, just to summarize, we provide the visibility that I mentioned in a passive manner. We are not complex, so there are no agents, no changes in the network required. And finally, we assist you with complying to many different regulatory standards, and have a strong presence in the Middle East with a large customer base. I want to thank you for listening to me. Please share any questions you may have, and I want to thank Oregon for giving me this opportunity to present to you today.
Thank you for that, Bachir. I think we had a question from Coyote, and we would be replying. And Ilan, I think that that would be the question that was posted earlier. That would be more on the Siga side. So appreciate your response on that as well, Ilan. So any questions to Bachir, please post it on the chat, and we would be glad to help you out with the same.
Thank you.
And the next up we have, so we've gone through the asset discovery and the threat intelligence and the asset intelligence, as Bachir just briefly explained, how we are actually achieving it with Nozomi. Now, we have a key solution which is coming up next. How do we securely transmit this data, or how do we store this data, encrypt it? And what about the data encryption, data in transit, data at rest? How do we securely store this data or transmit this data? So to talk about that, we do have this great partner, valued partner with us, who is from the US, and that is Secure Channels. They have been pioneering in the encryption technologies and reaching up to quantum level encryption algorithms and mechanisms using their patented technologies. So to talk about it, we have Ilan Searle from Secure Channels, and I would like to welcome him to this dais, please. Thank you. So Ilan, up to you.
Thank you very much. Let me know when you can see my screen.
So Ilan, yeah, we still have, it's not on the presentation mode. Sorry for that. Yeah.
All right. Get this fixed real quick here.
I can see the screen.
Okay.
Yeah.
Okay, great. Thank you again, both Siraj and Dr. Manu, for having us. We are very happy to be partnered with Oregon Systems. I just have a few slides. Primarily, we are in the business of cryptographic tools, platforms, and solutions. Everybody see the screen okay? Still making sure.
Yeah, it's not on the presentation mode, Ian. That's
okay.
Yeah.
Let me fix that here. Yeah, it doesn't want to.
Mr. Yan, I think you there is a function down at the bottom at the footer beside the way you could increase your
okay.
So there is something called slideshow. You could maybe click that. It should come up. The last option, the last one. Yes, that one. Correct.
Yeah, it's that's okay. As my predecessors have been talking about, the importance definitely on OT and IT networks and the deployment of IoT, IIoT, and smart sensors, as many in the infrastructure, critical infrastructure, are trying to pursue these modernization initiatives. The risk of actual data flowing from between point A and point B is still critical. And we know for a fact from statistics that the Middle East gets hit harder and more often than any other part in the world. And we know critical infrastructure is their target. One of the very nice things about our technology is it does not have to be deployed on brand new technology, as in there is no need for a greenfield upgrade. It can be deployed on existing technology as a bump in the wire. And I think the very first, one of the very first slides that Dr. Manu showed that had the high level architecture design had us down there on the layer 1, layer 2, where we can actually encrypt the communication in real time between, say, PLCs and HMIs. And I'll jump right to that slide. So there's a PLC and there's an HMI. We can actually encrypt because our encryption is so fast And because we do not rely on certificates or PKI or any of the things that most in the IT world really don't appreciate, I haven't met a customer yet that says, yeah, I love certificates or PKI. Most of the time, it's very much the opposite. So we can actually, our encryption actually encrypts in the nanosecond range, under a millisecond. So we can actually work in protocols like Goose, where in previous presentations, I was watching Nozomi Network, and they pointed out that Goose is one of the protocols that requires encryption in less than 2 or 3 milliseconds. So we actually fit in those environments. So we end up becoming a very unique solution for encrypting data between different devices in an OT and an ICS network. And then I've just got one more slide. Basically, it's the SANS 2019 cybersecurity survey that I like to bring up with my OT ICS customers that really points out the criticality of OT ICS cybersecurity, and the fact that the respondents, more than half, said cyber risk was high or severe or critical. The fact that lowering risk, again, is the 3rd highest overall. OT ICS controls was a leading business concern for the operation. And the top 2 threat categories were the things, IIoT devices, and external threats, which again kind of supports what we're doing here as far as a solution that Oregon systems can integrate. Thank you for letting me speak today.
Thank you, Ian. So that was a brief about Secure Channel and their the encryption technology, which can even be used, as he rightly mentioned, on low latency and where low compute devices like PLCs and RTUs are to be encrypted. The data from that are to be encrypted. So using their patented exotic technology, we can encrypt them even to the extent of around, I guess, if I'm not wrong, 13,000 bit. Yeah, right?
Actually much higher. It actually starts at 512-bit, and the very highest, which we wouldn't necessarily recommend for every application, usually more data at rest or archive, actually goes up to 131,000-bit.
That's unheard of. Yes. And
well into the post-quantum range.
Right, and many of the national security and critical organizations across the US and Europe are already using their technology. So we would be glad to bring this to the Middle East region, and with Secure Channel's help, we would be showcasing that in the upcoming further events as well. So next up, if you yes, and all the attendees, please, if you do have any questions for any of our panelists, please do shout out, just post the questions on the chat, and we'd be happy to help you out with that. We'll be clarifying that in the chat as well. And next, we have we have actually done a small lab demo for all our attendees. And Waqas Younas, he's our senior lead OT and IoT cybersecurity engineer, and I'm thrilled to introduce him to this panel. And he would be taking across a few certain scenarios or use cases that we see across this OT and IoT cybersecurity challenges in case, and the solutions, how we tackle them, how we reproduce them, and how we can troubleshoot, or how exactly we are securing these threats and vulnerabilities in the OT and IoT cybersecurity network. So Waqas, please take stage and show the magic. Thank you.
Hello, everyone. Thank you so much. Thank you, Nidhin, for the nice words. I will be sharing my screen. So this will be a quick demo on the systems Ilan has mentioned, and Bachir has already discussed about that. A few other solutions, we have it on board. We don't have the partners today in the session, but I will be able to demonstrate it, how the solutions are working. Let me share my screen, please. I hope everyone can see my screen.
Yes, Waqas. Thank you. Yes, perfect.
Yeah. So what we will be covering up in the lab is, since Ilan has already explained and Bashir has already explained, that how we will be protecting the layer zero assets and how we can stop the data forgery and insider threats from affecting the critical assets, and which will be eventually affecting the production line in the ICS networks. So how we can increase the visibility in using the Purdue model, how we can know what is running on the infrastructure and how we can protect it from these cybersecurity threats, how we can make an integrated network, right? And how we can protect the PLCs from any unauthorized access, and even the physical access from to those assets will not be like, say, if someone have the physical access to PLC, we will be able to still be able to detect it. How we will be able to do the micro segmentation in the network where OEMs networks are running and proprietary networks are running. Let's say they are not allowing majority of the vendors to connect into their infrastructure and not allowing any softwares to be installed. How we can do micro segmentation to clock down the different assets, how we will be restricting them. And let's say tomorrow if there is any kind of cyber security threat is happening, how we can stop it, the propagation between the network assets, and how it is going to be easier for the cybersecurity consultant or even the plant manager to manage this microsegmentation. We will be showcasing that, and how we can manage those assets which we are running in the plant network, and how we can give the secure access to those assets with the compliance and monitoring of all of the activities what they are performing, and how we can defend the parameter of the plant network and IT like say the segregation between these two zones, how we can protect it, that even we will be making the business continually uh, to ensure that you are continuously getting the data in your IT network for business decisions and your stakeholders, but still protecting the ICS control networks. So this will be our quick lab demonstration design, how this is gonna look like. I will be explaining it as we go through the session. All right, the first use case we have is from the Siga-OT, and Ilan has very well explained it. And one of the actually customer came back to us mentioning that they are facing the information inconsistency between the HMI and the actual critical assets. So they called their cybersecurity consultant, and actually he found out that one of the PLC has been infected by an insider threat, and they asked him to replicate that threat also. So he was successfully able to replicate that threat by modifying the OEM protocol and sending the forged information to the HMI system. So that was a typical example of like what happened in the Stuxnet, which Nidhin has already mentioned on the chat. So that was a similar attack happened in a few years back when actual asset was running on a different speed when but HMI operator was saying on a that everything is normal. Okay, that kind of threats cannot be happening when you have the Siga-OT systems in place, because we are completely passively and independently we are looking into the asset, what is happening, how that asset is behaving. We are using the machine learning to make those hidden anomalies rules and alerting the administrator that what is happening, so he can take the actionable in like all the insights will be actionable, so he can take better decision to make the plant running. So I have a quick demo about for this solution. Let me just go back to the system. All right, so sorry. Oh, sorry, it's here. Okay, so this is the dashboard of Siga-OT. Let's say we are, I'm just activating the system to start detecting all the threats and everything in the critical assets. So I have two systems running in my lab. One is oil tank and one is wind turbine. So I have purposely shut down the wind turbine. I have the oil tank running where we are continuously monitoring what is the pressure, sensors, and everything. So anytime, let's say if there is a cybersecurity threat, this is what you are going to see. Even the if let's say even the forge information is coming to your HMS system and you are not able to match that information, Siga-OT will be able to detect that what is happening with that asset actually. So it will be acting as a independent HMI console for your operators to verify the status of the device Is it safe to operate? Is it behaving properly, or is it under cybersecurity threat? You will be able to see completely what is happening with those assets. Every second, we are pulling the information from the analog signals, basically, or it could be digital signals as well. So we can see what is happening. Even for now, you can see one alert is there. We can even look into the alerts, what is happening, why that alert is there. For example, this one is, there is oil temperature has been changed, what time that happened, and if it is a cybersecurity threat as well, you will be able immediately able to not like get a notification on your screen that the asset is under threat, and the operator can completely match these two information. And if there is any inconsistency, since Siga-OT is a passively verifying that the asset is, let's say, running on a particular, let's say, for a particular speed, and HMI system is, let's say, responding with a different values, you can completely verify this information and take a better decision for your making that asset work. All right, I'm going back to these slides. The next demo we have is for Nozomi networks, and since Bachir has very well explained it, that we passively connect into the network and we identify what is running on the infrastructure, how that is working, where it is communicating, and what kind of protocols are running, what is the bandwidth, what is the vulnerabilities are running, and if there is even a way to attack the system, we can even see it. So this is one of the good use cases actually happened with one of our customer, that one of the person visited their plant and removed their printer and connected shark jack. If someone is not aware with the what is shark jack is just a dongle with scripts. You can run it, and actually you can equip it to detect what is there on the systems, find out the vulnerable machines and compromise the machines and get the data. You don't need a human interaction with that dongles basically. So someone just disconnected the this printer and just connected that kind of dongles. With that kind of sophisticated attacks, it's just an insider threat. Someone just plugged in, and these OEMs are not protecting those as those ports. I have worked like more than 10 years with these OEMs, and I have seen it that their switches are running with default configurations, no protections on their assets. So they lack this visibility that what is there and how that is working. So Nozomi networks, when it comes, we can passively connect into the network. We are looking into each and every communication, what is happening on it. And we are not tampering with the control systems basically. So we are, since Bashir mentioned that we are completely taking this information using span and R spans, and we can alert the administrators what is happening. Okay, anytime if there is, let's say, a new asset, we will be immediately able to identify it. And since we are on the layer 2 networks, and we can see each and every communication even between these two devices which are on the same network, same VLAN, same broadcast domains, we can assess what is happening, what kind of vulnerabilities are there, what are the risks available, what are the patches it's running on, and we can even see what is the cyber security threats are happening on it. So I have a quick demo about for this system as well. So going back to the system, I'm sorry. All right. So let me just close it. All right. So this is the dashboard for Nozomi networks. In this dashboard, you will be able to notice that we are able to see what are the assets running, what are the nodes are there, nodes in terms of what are the IP addresses are there, how many communication is happening on the network, what kind of protocols is running, and what kind of sessions is. And the dashboard is very clean, so it's easy for any even HMI operator to find out what is happening on their infrastructure. So we are grouping those devices with the Purdue model based, and we can know what kind of vulnerabilities are there, what kind of threats are happening. For example, let's take one of the assets, and we can see what is this asset, who is the manufacturer, and what kind of vulnerabilities are available for this asset. And let's say even we can actively go to the asset and see what is the patch level of those assets are. What Nozomi uniqueness is also in the behavior analysis and asset intelligence as well. It will be able to map the behavior of the device once it's in the learning mode, and once it's converted to the protect mode, we can know that if the asset is behaving in a way which is it should not be. All right, so we will be able to see even what kind of variables they are exchanging between the protocols. Even these are OEM protocols. That's what they have a lot of partnership with all the, as like even it could be VNet and other systems where we can completely know what kind of protocols are these and what kind of data is getting exchanged. Okay, we can go into the environments and we can see what kind of assets are on the network. All right, and we can even see what kind of communications are happening, what kind of protocols are running, and even we can make it into a graph view for easier identification. And we can even see what kind of attack paths are available in the network from where these assets can be accessed. So you know that which assets are getting communicated from, how many assets are communicating with those assets, and how they are behaving. So you will be able to completely detect what is happening on the network. So I'm going back. Please feel free to put the questions in the chat section. Nidhin will be taking care of that. So the next session we have is for ConsoleWorks. ConsoleWorks is a solution where basically we are handling three major challenges. One is asset management, how to manage those assets when you, let's say Nozomi has detected, okay, these are the, let's say, thousands of assets. How you will be managing those assets? We can do it through the ConsoleWorks management in terms of it, like we can do the baselining of it, like this is the configuration of it, and anytime there is a change, we will be able to detect it. Who is accessing those assets? What will be the privileges for those users, and what they can do, and what has happened in the past as well. We will have a complete recording of the sessions, what they have did, what kind of keystrokes they have passed. All this information is logged, and anytime if the compliance comes up and it's not matching with the compliance policy, we will be able to identify those kind of gaps and notify the, let's say, manager or plant admins that this is the gap, this is the user who violated these policies. And even in this COVID situation, there is one of the very interesting use cases happened with our customers, like a remote accessing the systems, but with in a secure manner. We are not allowing all the protocols to run here and there, or we are just allowing HTTPS for the users to access the ConsoleWorks, and they will be, once they are authenticated with 2FA, and we will be able to control what they can do, what kind of assets they can see. They don't even need to know the passwords for those assets. All right, and we will have complete different access for each user or each operator, and even different vendors are coming on site. We can create different access for them. We will be able to completely see what kind of threats are there. Let's say all the logging we are keeping it, we can digest the syslog logs as well. And even we can do the password management. That is one of the challenges with our most of the ICS network, that it's very hard to change the password for all the assets, since it's in the assets are in thousands, even in I have seen it in millions as well. So we cannot go to each device or even do the SSH and change it. So that is where our ConsoleWorks comes in, and it can change those passwords automatically and even make a workflow. Let's say they change it for application and then change it for PLCs, and send a secure list to the end and to the plant manager in an encrypted format. And even we can integrate with the asset and patch management solutions, basically where this information can be digested, and even we can see what kind of vulnerabilities are there on these assets. I have a quick demo for this one. Let's say we have a remote user who will be coming from, let's say, internet, or even inside the plant as well. If it's a operator, he will be just seeing that console over the HTTPS. He don't have any other access. So this is the dashboard, what he will be seeing it. Let's say if he is an HMI operator, I will just change his profile. Once he logs in, he will be just able to see this one. And what are the assets accessible for him? He will be able to notice, and he cannot edit this configuration. And once he just have to click connect, and he have the assets on the other side. He don't have to pass the passwords or provide any kind of credentials for the end host. Once he's authenticated with the ConsoleWorks, he will be able to access the end device. I believe the asset is in the shutdown state, happens somehow. Apologies for it. Let me just quickly show. It's a VM network, so sometimes it gets suspended. All right, so let me go to quickly troubleshoot it. Oh yes, it got shut down somehow. All right, once this comes up, we will be able to completely access that system. Just let me just try again. All right. It's just coming up, I guess, too. Not yet still. Oh, come on. Sorry, I guess the machine was switched off, so it is taking some time to just power on. I'll just take another minute and then we can connect it. Yes, sorry, the machine was switched off. So once, let's say the administrator or operator comes up, he just have to click it and he will be able to access the system. Whatever he does, we are completely recording it. You can see the icon on bottom of the screen. So whatever is happening, we are completely recording where he is clicking, what kind of like actions he's performing. Let's say I'm creating a new file for here just to showcase. All right, I'm just close this one. All right, I created a new file. So once the session is disconnected, we are even the plant manager can jump into the same session, or the security administrator can jump into the same session, and they can correlate this information. And we can he cannot see all the recordings and everything. We can just go back to as an administrator, and we can see what kind of actions has been performed on this device. We can just quickly go back to the same asset. For example, I want to see what happened and who logged into that device. All right, so you can see the recordings. Let's say I play it. So you have the complete information, who logged in, what time, what he does, and what kind of actions has been performed. All right, and let me just play this recording so that we know, okay, what happened. So for example, the guy from start till end of the session, we have the complete recording that who does it and who has logged into that session. So you will be able to see I have created a new files, and so even this recording can be offloaded to the systems and sent it for compliance purposes as well. And the same thing we are doing it with the SSH protocol as well, or telnet protocol. It could be a serial connection as well. So if we can even create a jump servers. Let's say in you have in the plant terminal server, we can even jump it, and the end user will not even know where that asset is. We are completely hiding that whole information from him. He don't need to see that kind of information. We can even restrict what he can do. And the interesting thing here comes up is like in this situation that let's say the remote desktop solution, wherever you have seen it, usually you are able to copy paste the things, file transfer, and even there are malwares which can automatically propagate through these sessions. So we are completely eliminating that whole possibility that they cannot copy or paste. They cannot do any kind of transfer from their system to the ICS system. Even we can create the read-only access for them. They can only see, they cannot control the systems. So it depends all on the policies, what kind of policies we are creating. Hope that gives an idea like what it does and how we are handling this information. All right, so let me go back to the next session. We have a short, it's a very short presentations and short demos, sorry. All right. So the next one we have is the how we are going to protect the PLCs from any unauthorized access, and how we are able to detect if the protocol, what we are, let's say if it's a Modbus or Siemens protocol is running, S7 is running. So how we are going to protect the communication between HMI system and or even the HMI console from where you will be controlling these PLCs. What kind of commands can be sent to it, what kind of modifications can be done. That is where SCADA fuse comes up. It's also named as OT fuse basically, which is the new name. So from this OT fuse, we are able to completely control what kind of modification can be done and what kind of commands can be sent to the end device, which is basically the PLC. And one interesting feature is there in the OT fuse is that don't allow any kind of modification to this system unless there is a security dongle. If you can see it in the picture, you can see this white dongle is connected. Unless this security dongle is not there, even someone have a physical access to this box, he cannot modify the configuration of it. And the uniqueness in OT-Fuse comes up from the architecture prospect as well, that it can learn what is happening on the network. Let's say you don't need to create the policies, and you don't need to be expert on creating these policies between, let's say, control system and OT-Fuse. You can just put it to learn mode. Any plant manager can do that. And once it has learned what is kind of traffic you are moving between the PLC and your control system, you can then put it to the protect mode. So that is from where it will start protecting. This is the architecture we have created in the lab as well, that anytime you will try to pass on the command which is not authorized, it will immediately block that. Even the protocols, let's say if the protocol, you have allowed it a read only access and it is trying to write, you will be notified that someone is trying to write on these PLCs and it's been blocked. We can offload this whole information to your SIM solutions or syslog solutions, from where you can monitor and take actions on it. So the screen, you can see it on the top right, that is basically the OT-Fuse console, from where you will be, you need a second dongle as well to modify this configuration. I have it in the lab as well. All right, so this screen, let me just minimize the other one so you can properly see. So this is the console from where you will be able to modify this. Let's say you have maybe hundreds of scarafies, you will be automatically able to see it in the list. It automatically keeps detecting it. And once the dongle matches that, yes, the dongle is valid, which is basically connected to the system, and the other dongle list is, if you see this number, the other dongle is connected to the node. So unless these dongles are not authenticated, you cannot modify the configuration. So from here, you can modify all of its basic parameters, like what will the IP address is and all those things. You can even go back to, once it's configured, you have the consoles basically, which will be a very simple and straightforward interface. Any plant admin can log in and modify the configuration. Let me just log in. All right, so this is the dashboard for OT-Fuse, from where you will be converting it from, let's say you have kept it in the learn mode, you will be able to completely make this policy that what is happening, what kind of traffic is moving, you will, but we will not be taking any kind of actions on it. So we are not, unless you don't put it to protect mode, we are just learning the traffic or monitoring it, but we are not taking any actions on it. So it's creating a new policy. Let's say you have a new protocol. It's very straightforward. It's very simple to just select the protocol. Let's say if it is an maybe a Modbus or S7 or whichever the protocols is. So you will be able to control, is it going to be read only, or is it going to be let's say complete full privileges will be on that PLC, or even you can make a policy that if someone tries to modify the PLC state, let's say if it is on, he's trying to make off, you can configure this kind of policies in the advanced section, so that critical assets or the which are connected to the PLC, it's completely protected by even the accidental, or it could be a cybersecurity threat. It will be completely protected. You can see what kind of, let's say if there is an event happened in terms of cybersecurity, or any unauthorized access happened, you will be able to see it. They can acknowledge it, and this information can be displayed on your SIM solutions as well, that someone is trying to access those PLCs and there is an unauthorized access. It's very simple, very straightforward product. And the interesting thing in OT-Fuse is it completely goes down, your network is not affected, since we understand that critical assets are connected to the production, and all the time there is, anytime if it is down, there is always going to be business loss. So even the system hardware or by software, it goes down, you will still be, the network will continue working, because we have the inline pair, and it will not be affecting the systems. Hope that giving you the idea how that works. The next quick demo we have is for tempered networks. That is which Dr. Manu was mentioning. So in this solution, what we are doing is, like, since the OEMs are not allowing the micro segmentation to be deployed in their infrastructure, claiming that okay, you don't cannot change the physical infrastructure, you cannot modify this and that and all those things. So we are keeping everything in mind, and we partner with the Temper Network. What it does, without modifying the physical or their underlay network. What is the underlay network? Which is actually deployed by the OEMs basically. So without modifying their OEM networks, we are deploying an overlay network. The overlay network will be basically what it will be: a logical communication between two devices, okay, which will be completely hiding all the infrastructure from any kind of cybersecurity threats. They are connected to the same zone, or what is the same zone? It could be same VLAN, like even the same zone IP addresses. They will not be able to communicate unless there is a trust between the network. Let's say two devices are there, they need to communicate. There needs to be a trust between those assets so that they can communicate. And we are not just relying on the IP address. The difference between tempered and other devices and other micro segmentation solutions is their uniqueness in the approach. So we are not just relying on the layer 3 protocol, which is OSI model. We are introducing another layer 3.5, where we are adding a HIP identity, host identity protocol, which will be a cryptographic identity for each asset. And based on this cryptographic identity, we are able to create the overlay networks, and we, regardless wherever they are connected, you for or the network, it will be like even they are in the same zone, we will be able to control them and what kind of communication they can do. And any plant admin can very easily modify, because it's a completely GUI interface, drop, drag and drop kind of configuration. You don't need to manage the CLIs and like complex policies on other vendors. So this protocol, what it does, it completely eliminates few major cybersecurity threat. One is man in the middle attack. So there is no possibility of man in the middle attacks. No one can basically forge the identity. No one can spoof the identity basically. So because this identity, without this identity, without the trust, you cannot even see what are the other assets on the network. Even you do the port scan, you can do any kind of nmap scans, and even try to communicate, you will not even see the request coming from those assets. So if you remember the cybersecurity kill chain, in that one, we, out of the 7 steps, we just need to eliminate one to completely eliminate the kill chain. So here what we are doing is we are making the micro segmentation for each zone. Each device can have its own micro segmentation. And if you see on the picture that is a cable connected to it, it's a graphical visualization of those assets. So unless the trust is not built in, they will not be able to communicate. This network cannot be DDoS. Even we are prone to that kind of attacks, which are normal to IP networks. Once this tempered network is deployed, it could be a hardware or software deployed. Once this is deployed and the trust is building, the network is completely hidden. Unless any asset is not having the trust or not part of the overlay network, it cannot communicate. So I will just quickly go to the demo of that one. And in this demo, I will try to showcase like how easy it's gonna be for any plant admin to, let's say, create a new overlay or how to manage that easily. Let me just go back. All right. So I have the conductor system running, which is basically the management console for all the airwalls. The airwall will be a physical device connected to the end devices. All right. So I have two airwalls running in the network. So for example, these are the devices. It is automatically learned from the network that these are the new devices on that, what is the IP addresses, and even we can see what is the cryptographic identity has been assigned to it. So based on this one, so this cannot be forged. We can create any kind of policies behind this one. Let's say we can create a simple overlay network to mention that okay, these two devices needs to communicate. I have the OPC servers running, so I will name it OPC overlay, or let's say a new one. So just I'm trying to demonstrate like it's going to be very easy for any administrator to create this kind of policies. He just have to select, all right, so let's say OPC client and OPC server, I have it. All right, he just have to add it. So once these devices are added, you can see in the visualization that we have two devices. but currently they are not allowed to communicate. I have these devices running here. Let me open one of the device so we can try to ping it and see if the policy is working. All right, so logging in. All right, so I have OPC client running on this one. So I will just open it and try to ping the server, and we can see currently even they are having the same zone IP addresses, same subnet range, and connected to the same VLANs basically, but they are not able to communicate. So let me just quickly log in into it. All right. So I have my server running. Currently, they are not able to communicate basically because you have added these devices, but you have not created the trust between them. So how to create a trust? It's very simple. Let's say you want this OPC client to communicate with OPC server. If you notice, there is an icon highlighted. So you just have to click it and the trust is built in. So once this trust is there, you can see that icon is this line is into the blue color. So now the trust is built in, and now they will be able to communicate with each other, and any plant admin can very easily make this kind of policy just to select from where this asset is going to communicate and which will be the destination. So the micro segmentation is not going to be a headache once it's set up properly. Okay, this is the server, we have it running, and we have the client. Now if I try to communicate with the assets, so I should be able to do that in just since it just takes some few seconds to deploy. Yes, so once it's now if you notice, we are able to reach the destination server. All right, so that's how we create the trust between the systems. And once the trust is built, you will be able to monitor these devices, what is happening, and even we can see what kind of packets has been transferred. We can capture everything from here. We can even create a like intrusion prevention policies on these systems, and that is not going to be like you have seen it in the normal firewalls, and it's very hard to create those kind of policies. Let's say I go to the device, and you have all the rules in a group manner, from where you will be selecting just what you want to do. For example, you want to deploy the IPS rules on intrusion prevention rules on the file transfer. You can see it, what kind of rules are included. Let's say what kind of files can be transferred, and you can create an action on that one. It could be a block, it could be forward, it could be an alert, or completely disable that connection. So by this way, we are completely like making a simple micro segmentation where we are making all the devices completely invisible from the cybersecurity threats. We are creating the zones between the network in usual modes in the plant networks. If you have noticed, they are usually all the OEMs are deploying one firewall on the DMZ, and that's it. And that firewall, I have personally seen it in years, it's never updated. So that kind of challenges actually increase the cybersecurity attack surface. And once you have the overlay networks deployed, even the systems are old, we are limiting the attack surface. Anytime any asset, if let's say it's compromised, it's just compromising that overlay network. It cannot propagate to all of the network. Hope that giving you the idea how that things work basically. So the last demo we have is how we are protecting the parameters basically. So in like I have seen it, still a few networks are completely segregated in terms of they are not exchanging the information. They are just taking the information in a month one time, and you are missing very critical information between this 1 month. It could have been like completely change of business plan. All right, so how we are protecting that is we are using the data diodes with like most of our customers are using it. How that data diode works is we are completely physically segregating between two zones, IoT and IT, using the diodes. For we have blue diode and red diode. The blue diode is only equipped by for sending the information, and the red side is can only receive it. So what kind of communications we can pass through it in a unidirectional manner is it could be a OPC connection, it could be pi systems, it could be file transfer, it could be syslog, it could be emails, and even it could be OPC, DA, UA, or AE connections. All right. So even what we have with one of our customer deployment is we can completely take this whole raw information from the ICS network in the Ethernet frames basically, and you take it to the IT section where you have a SIM solution or analysis engine or predictive clouds are there, or you have, let's say, Nozomi devices out there which are expecting the span traffic to come in. So that kind of all the information we can take it from the ICS zone securely, we can transfer it to the other side, keeping the confidentiality of both zones without like there is no zero possibility for any attacker to compromise the data diode and go to the blue zone, and which is actually connected to the ICS network, because we don't have that capability in the hardware itself. We are not relying on the software to do this kind of change. So I have a quick demonstration, very simple. I have just created a demonstration with the file transfer basically. So I can just open the server for both of the sides. I have one server on the blue side and one on the red side. So let me just log in into these devices. All right, and I have the red machine. So this is this is OPDS test red. This is going to be my destination for the files. So I have a script running which actually keeps monitoring the folders, that anytime any information is kept on those folders, let's say any new file has been created in the source server. This is the test blue, which is the source. So anytime if you create that file, or you have copied the file, or any of your system has automatically generated that file and kept it in that folder, so this script will automatically take that information and will be able to send it to the diode automatically. It could be a Pi system as well, which is automatically getting connected. For example, I just copied one of the files and just put it into the folder. So you will notice immediately the script is able to detect that there is a new file. It taken that file and moved it to the diode, and once it successfully moves, we have deleted it file from the source. It could be like disabled as well, that to don't disable it. On the right side, if we notice that we have already received a connection where we have copied some file, that's and it is kept on a certain folder. It's a configuration we can do it, that where this configuration will go. Let's say new file has received, where this file will go, we can immediately see the file is received. So this kind of communication, it could be an FTP, SMB, it could be any syslog server, or any kind of OPC servers are there. We can take that whole information and give it to the business side, where the business analysis can be happening in a secure manner. We are completely keeping the confidentiality of both zones. So we are at the end of our presentation. I would hand back the session to Nidhin. Thank you for the time.
Thank you, Waqas. Thank you for that lab demo and the presentation. So I just wanted to run it from the top, just before we go to a 5-minute quick question and answer session. So we saw the importance of level 0 monitoring, why exactly it is needed in this region, and also to protect against anomaly detection and data forgery using Siga-OT solutions. We saw the importance of Nozomi asset discovery and the threat intelligence and behavior analysis associated with any asset from level 1 up until the level 4, both in OT as well as in IT network. We just had a brief discussion about secure channels and the quantum encryption technologies, which provides low latency, low compute solutions from secure channels exotic algorithm. And also we saw the lab demo demonstrating some of our use cases on Siga-OT We saw the asset discovery using Nozomi and the threats and the suspicious activities and the network graph, which was beautifully done by Nozomi Networks dashboard. The asset management, we had a couple of questions on that, I believe, and that was on the the profiles and a user, how we can securely move or give access control to, say, different profiles or different users from both OT as well as IT. We saw the data diode solution and the secure cloaking mechanism using tempered networks, which is a very interesting technology. And due to the shortage of time, please feel free to contact us after the event if you need to know any of these technologies in detail. So we are open to any question and answers from any of our panel members or attendees. So please feel free.
Wonderful. Then I think most of the questions have been answered by Mr. Nidhin. The questions were exciting. I did see a couple of engagement on the chat as well. And thank you, Oregon, for actually taking the session up. I mean, it was an exhaustive session. We had a lot of information shared during the details. And I also thank the vendor partners here participating, Secure Channels, Nozomi Networks, and Siga-OT here. And wonderful demonstration by the team from Oregon showing us on hands-on demonstration how things are done and how well you could secure your network too. With this, I would conclude the session for today, and we move on to our next session, which is at 10:45 to be exact. We take a short break here.